Before you start Lesson 51, make sure you have completed Test J in your Test Masters, and also make sure you've done Investigation 5 on the pages preceding Lesson 51. And that investigation is about creating graphs. Lesson 51 is about scientific notation for larger numbers, and this will be an application of what you learned in Lesson 47 about powers of 10. Remember, in that lesson, one thing that we learned was, say we had 3.1 times 10 to the third. We learned that if we looked at our power, we would just move our decimal place to the right corresponding to that power. If we have 10 to the third, that means we move the decimal place to the right 3. And so we'd have 1, 2, 3, and we'd end up with 3,100 for our answer, 3,100. That's the same thing as 3.1 times 10 to the third. Now, actually, that 3.1 times 10 to the third, that's what is called scientific notation. It's a way to write really big numbers in a more simplified manner. To write something in standard scientific notation form, you just have a digit that's in the ones place, and that's it. You don't have one in the tens or the hundreds place or anything like that. You just have a digit in the ones place and then decimals or a decimal after that times 10 to whatever power it is. So look at practice problem A. How do you think you would write that in scientific notation? So remember what I said about scientific notation. You have the decimal point right after the ones place. So you just have one digit to the left of the decimal point. Right now, our decimal point is right here. So that means we need to move it over 1, 2, 3, 4, 5, 6, 7 to get it to the right of that ones place. That means our answer is 1.6 times 10 to the 7th. Since we moved it over 7, our answer is 1.6 times 10 to the 7th. That's the standard scientific notation form for 16 million, basically. And that's important to understand when you're doing scientific notation. There's a standard way to do it. And that standard way is that you have that decimal point to the right of the ones place. So there's only one digit to the left of the decimal point. Not 2 or 3 or 4. There's always one digit to the left of the decimal point. That's the standard scientific notation form. One non-zero digit to the left of the decimal point. See if you can figure out how to do practice problem B in standard scientific notation form. Well, all you do is you start, the decimal point is right here. You know you need it to the right of that first digit to the right of that 3, so that means you'll need to move it 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 places. That means you'll have 3.0 times 10 to the 11th power. That's your standard scientific notation form. 3 times 10, 11 times over, is equal to 300 billion. Let's try to do practice problem C. Do it the same way you did A and B. Just move that decimal place to the left until you get it in front of the first non-zero digit. So to write that in standard form, you'd move it 1, 2, 3, 4, 5, 6 places. So that means 10 to the 6th. 4 point, you can't just leave that 7 out that's over there. So you have to say 4.007 times 10 to the 6th, which would be 4,007,000. 4.007 times a million. That's what 10 to the 6th is, right? Is a million. 4.007 times a million is equal to 4,007,000. Now let's just think about something for a second. Why would you need scientific notation? Well, there's a couple of reasons. One reason is when you're working with really large numbers, larger than the ones that we're working with right now. It's a real pain to have to write out all of those zeros, so it's just so much easier to put 3.0 times 10 to the 11th than writing out 300 billion with all of those zeros. That's one reason you use scientific notation, is to make it easier to write a really large number. And another reason is because on your calculator can only display so many digits. And let's say you had like 5 times 10 to the 57th. There's no way your calculator could write that many zeros on the screen. That's where scientific notation comes in handy. It allows your calculator a way to write something in scientific notation form, or write a really large number and still be able to do calculations of really big numbers. Now let's go the other way, and you kind of know how to do this already in problems D and E. Write those in just the standard form that you would write a number. And so what you need to think about there is on 3.7 times 10 to the 7th, you need to move that decimal place to the right 7 places. That's what 10 to the 7th means, is you're moving the decimal place over 7 places. So I'm just going to do like I usually do. 1, 2, 3, 4, 5, 6, 7. Make those little marks, and I'll put a 0 inside each one to help me remember how many zeros I'm going to end up with. And it's a good idea to do that, to write that down instead of trying to do it all in your head, because you can miss just 1 0 and you get the whole problem wrong. And then go back and put your commas in every 3 places, and so you end up with 37 million. Hopefully that makes sense to you, because 10 to the 6th is 1 million, 10 to the 7th is 10 million. So really what you're doing there is 10 million times 3.7, which would be 37 million. And then on E, you have 5 times 10 to the 4th. Now maybe that one you can do in your head a little bit easier, because you just have a 5, and then you know you need 4 zeros. 1, 2, 3, 4. 50,000 is the answer there. Look at problem F. I want you to tell me which of those numbers is greater. Is one greater, one less, or are they both equal to each other? Well, you have 5.3 times 10 to the 8th and 3.5 times 10 to the 9th. And if you just glance at it real quick, you'll say, oh, well, 5.3 is greater than 3.5. But wait, you've got to look at your powers too. And you have 10 to the 9th on the right. So basically you're saying 3.5 times a billion, or 5.3 times 100 million. 3.5 times a billion has to be greater. So 5.3 times 10 to the 8th is less than 3.5 times 10 to the 9th. And then one more. Compare 1 billion and 10 to the 9th. Well, hopefully you already know that 1 billionth, or 1 billion, is 10 to the 9th. So those things are representing equal quantities. 1 billion equals 10 to the 9th. Scientific notation is just a simplified way of writing a really large number. If you want to write something in standard scientific notation format, you move the decimal place over until it's in front of that first non-zero number. However many places you moved it over, that's your power for your power of 10. Okay, well that's all for lesson 51.